I'll discuss Quadratic-INE-B. So question number 5. Now this rational function of x is given. Let's assume that equals to y. X minus a into x minus b. X minus a into x minus c over x minus b. And it's given that a, b, c are in ascending order. So a is the smallest one, then b, and then c. A less than b, less than c. Right, and now we have to show this expression can take all real values. Y can take all real values, or we can say the range of this expression is y belongs to R for all values of x, of course excluding b, which is not part of the domain. We have to show this expression can take all real values, so we can say y belongs to R to show range is all values, or to show y belongs to R. Now you know it's a typical approach, typical method. We cross multiply with denominator, express as quadratic in x, and as x belongs to R for all values of x, for all x belongs to R, we put d greater than equals to 0. Let's do that. Cross multiply, it is yx minus yb equals to x square minus a plus c into x plus ac. Now express in a quadratic form, x square minus a plus c minus y a plus c minus have taken common, so plus y into x plus ac plus yb equals to 0. Right, and now we put d greater than equals to 0. That is a plus c plus y whole square minus 4 ac plus yb greater than equals to 0. Now we express this as quadratic in y. It's a quadratic in y, quadratic inequality in y. Express in a proper form, proper quadratic form. It is like we get y square from this side, and then we have 2y a plus c. I'm taking a plus c as one unit. That is 2y into a plus c plus a plus c whole square minus 4ac minus 4yb greater than or equals to 0. Now we have to show this. We can simplify this first. Y square, we combine, we take 2y common, inside we get a plus c, and when we take 2y common from this, leftover is minus 2b, and a plus c whole square minus 4ac. It's like a plus b whole square minus 4ab formula. That's a minus b whole square. In this case it is a minus c whole square greater than or equals to 0. Now you know this expression takes all real values, means that the graph of this quadratic expression should be like this. Either should be like this, either like this touching, or it should be above. Of course we are taking y as independent variable, so this expression is a quadratic expression, and graph of a quadratic expression is a parabola. So it takes always positive values, always greater than or equals to 0, means whatever y you replace, this should always be greater than or equals to 0. For every value of y, it should be greater than or equals to 0, and that's only possible when d is less than 0, discriminant is less than 0, and of course coefficient of y square is greater than 0, and it's already positive. Coefficient of y square is positive, parabola opens up, so d should be less than 0. For d it should be less than 0, b square minus 4ac, so 4a plus c minus 2b whole square minus 4a minus c whole square. Now we have to show this should be less than 0. Assume this expression as the, we take 4 out, a square minus b square formula. We'll factorize it using a square minus b square. So first factor is a plus c minus 2b plus a minus c, right? And then second factor is a plus c minus 2b minus a plus c. We have to show this expression is negative. This is a d expression and we have to show d negative. And this is 4 times. We can cancel c with c, so it is 2 times a minus b, and this is again 2 times, we cancel out a with a, 2 times c minus b, so it is 16 times a minus b into c minus b. Now you can see a minus b, this is positive. From here you can see a is greater than b, ascending order, so c is the greatest. This is positive and this one is negative because a is smaller than b. This is positive and the product of negative and positive is negative, so this is less than 0. So you can see we are successful in showing that discriminant of this quadratic in y is less than 0, and we could show this because it is given that b lies between a and c. Now as discriminant of this less than 0, it means this quadratic expression is positive whatever value of y you take, whatever y you take, whatever y you take. So that's why y belongs to R. The solution set of this inequality is y belongs to R, and that's what we were supposed to show in this question.